Dear students, today I will discuss about classification of force. But the classification of force depends on various factors. In which respect you classified the forces, it depends how the classification will be. But fundamentally, if we talk about the fundamental interaction or the fundamental force, there are basically four types of fundamental interaction. And in this class, actually I like to discuss about these four fundamental interaction which are always occurred in nature. But in mechanics, the course that is going on, or this course which is for the JEE Main, NEET and JEE Advanced, in this course, here actually I am discussing about classical mechanics, or more clearly you can say mechanics. But in mechanics, we are encounters different kind of force, that is some contact force and some non-contact force. Actually basically in Newton's law or friction, in these chapters basically we discuss about contact forces like tensional force, normal reaction, frictional force. So there is different aspects of classified the forces in mechanics. But before doing this, before the classified the forces in respect to mechanics, but in viewpoint of mechanics, you can say in macroscopic viewpoint, which depends on various factors. How we want to classify the forces, it depends on that, what types of classification are there. But if you talk about the very fundamental thing about forces, then it can be classified only in four categories. These are the actually fundamental forces occurring in nature, or the very fundamental interaction in nature, that is four fundamental interaction. And these interactions are classified mainly based on actually interaction or exchange particle, mainly based on exchange particle. So this is actually you can say the microscopic viewpoint. But whatever force you can say like normal reaction, frictional force, tensional force, whatever force you can say, these all things will finally fall into any one of this category, any one of these four categories. This is actually the basic classification of forces. So before going to classify the forces in mechanics, the forces which we will be encountered in mechanics are different. I will classify them in various respects in the next class. But before doing this, it is my duty to inform you the more fundamental interaction which are occurring in nature. And these four fundamental interactions are strong interaction, electromagnetic interaction, weak interaction and gravitational interaction. These four are the basic interaction and the fundamental interaction, which actually based on the exchange particles. For different interaction, different exchange particles are responsible. We will discuss this thing also. But initially, I like to inform you that any force, any interaction you can say in your mechanics or other branch of physics, wherever you talk about interaction or force, whatever force you can say, the forces obviously will fall any one of this category. Like if you talk about tensional force, that is on the electromagnetic interaction. If you talk about a normal reaction, frictional force are on electromagnetic interaction. Actually are the electromagnetic force. I will discuss this thing later on, why these are electromagnetic force. That's why I want to discuss this thing initially, the fundamental forces, the fundamental interaction. Though this is the subject of particle physics actually, but I like to discuss over here for just your conceptual clarity. Okay, so let me talk about these forces. So here are four interactions: strong, electromagnetic, weak and gravitational interaction. And I think more or less you are familiar with these 2 and 4, that is electromagnetic and this gravitational interaction. But these two are being 11 students or 10 plus 2 student, you maybe you don't know these two types of force, strong and weak. Okay, but actually these strong force basically are actually nuclear force, and this weak interaction is also responsible or also occur in a certain kind of nuclear phenomena, that is actually the beta decay. Okay, when beta decay is occurred, then weak interactions appear. But this electromagnetic and gravitational interaction, more or less you are familiar. That gravitational interaction you know, that is proportional to m1 m2 proportional to 1 by r square, that is gm1 m2 by r square. Similarly, electromagnetic force is very complicated actually. The forces that you know is not actually electromagnetic force, that is electric force, that is two charge particle when it rest, the Coulomb's force like that. This is not actually the general form of electromagnetic force. So the general form of electromagnetic force is very complicated. This is the thing of electrodynamics. I will not discuss over here. But you can understand it in this manner, that electric and magnetic force both will be there. Okay, and there should some interaction between electric and magnetic field. There are some various potential called vector potential, etc. There are many things, but we don't need to understand that things right now. So right now we have to understand that there are 4 types of interaction, and I want to know the range first, and then the particle that filling this interaction, then relative strength, then exchange particles and effect of them. Okay, I just like to inform you this thing. You don't need to memorize all these things. You just have to understand that there are these 4 kind of interaction, and whatever forces we are going to interact in classical mechanics will be finally land into any one of this category, and we will discuss this thing later. Okay, so now let me understand this thing. So first I like to discuss about range. Up to what range these forces will appear, or these forces will valid, or they're effective, you can say. So from this data you can see that strong and weak forces, which are basically nuclear forces, or you can say responsible for some nuclear phenomena, these are actually short range forces. You can see from here 10 to the power minus 15 meter and 10 to the power minus 17 meter. So this is typically the nuclear radius, 10 to the power minus 15 meter, and this is slightly less. Okay, but this is actually nuclear radius. So if you can imagine by seeing this magnitude, that is 10 to the minus 15 meter or 10 to the minus 17 meter, that is a very short range force. This weak and strong interactions, which are basically for you, some unknown particles will feel this force for you right now. You don't, I think you don't familiar with these types of particles like hadrons, quarks. Okay, so don't worry. Just you remember these things. You can remember actually. If you don't want to remember, no problem. But you just see this picture as a picture. You can right now you can understand these things. There are some types of particles like hadrons, quarks, mesons, gluons, etc. Some types of particles are there. You don't need to understand this particle in details now. Okay, in the advanced course, if you want to know, or if you want to understand in advanced course of particle physics, you will automatically know. So now don't worry. Okay, so these strong and weak interactions are very short range force, and this electromagnetic and gravitational interaction are long range force. The range is infinity. You know, two charged particles experience this electromagnetic force, and this electromagnetic force are long range force. Okay, in fact mathematically it is long range force, because if you talk about simple electric force, that is A proportional to Q1 Q2 over R square, this is of course one type of electromagnetic force. It's a special case, maybe the charge is at rest, but this is also electromagnetic force. This is not the general form, but this is also electromagnetic force. So we can understand by using Coulomb's law, F proportional to Q1 Q2 over R square. So basically it is proportional to 1 by R square. Basically it's inversely proportional to distance. So only if R tends to infinity, then this force F will be 0. So you can imagine that the range of this force should be infinity. Similarly for the gravitational force, you know that this is Gm1 m2 over R square. So this is also inversely proportional to distance. So it will also be an infinite range force. Okay, in range means up to what distance the force will be effective. Okay, so these forces are effective, in fact mathematically, up to infinity. Though its intensity will be less after a large distance, but mathematically we can say there is some intensity. Maybe it's negligible, but there's some intensity of this force. Okay, so this is actually a range of these 4 kinds of interaction, and the particle feeling this interaction. What kind of particles feel this interaction? First you need to know about these 2 forces, strong and weak. Strong and weak, the strong force and weak force, or the strong interaction and weak interactions feels some kinds of particles like these hadrons, quarks, leptons. These kinds of particles feel these forces. You might don't know this type of particles, that is hadrons, quarks and leptons. So don't worry, you don't need to know about these things. Okay, just you can remember that there are something such kind of things that are called actually hadrons, quarks. Some types of particles are there actually that particles follow this interaction or they feel this interaction, strong interaction. Similarly, feel electrons. I can understand you simply by using this term. You might have heard that the strong force is actually the nuclear force, and the nuclear force is responsible for meson particle, pi meson, pi plus, pi naught, pi minus meson particles, and that meson particles are actually hadrons. They are actually hadrons. Okay, so there are some classification of particles. Something calls leptons, something calls hadrons. There are some classification, but in this stage you don't need to know this. You just remember as a picture that this strong force is applicable for these types of particles, or you can say these particles, these hadrons and quarks, these particles actually feels this strong force. Similarly, weak force feels leptons. But electromagnetic force and gravitational force, these two forces are familiar with you actually, more or less familiar with you, these two forces. You are familiar with this thing. And you know that electromagnetic force feels any charge particle. All charge particle feels this electromagnetic force. Electric force as well as magnetic force as well as in general electromagnetic force. All charge particles feels. But for gravitational force, you know all particles which have mass. All particles which have mass feels gravitational interaction. Okay. So these are the particles who feels this types of interaction, this four interaction. And the relative strength. What is the relative strength? Relative strength means which one is stronger than other, which one is weaker than other. We'll discuss here in this thing, that is the relative strength. And for that we choose this strong force as 1. If we choose this strong force as a standard unit, then we can compare the other forces with respect to these strong forces. Here you can see that this electromagnetic is 10 to the power minus 12 times. So here you can see all these things, all this relative strength which are comparable with these strong forces are always 10 to the power minus something. So these all are actually less than the strong force. The intensity, the strength of all these forces are actually less than the strong forces. So you can see from here, this electromagnetic force is 10 to the power minus 12 times strong force, and weak forces is 10 to the power minus 5 times, and gravitational force is 10 to the power minus 39 times. So you can imagine this gravitational force, how small this gravitational force is. That is 10 to the power minus 13 times, 39 times the strong force. So maybe the name of this force is weak, but this gravitational interaction is more weaker than this. This is 10 to the power minus 39. Can you imagine how small this force is? Okay, so these are the relative strength. These are the comparable term actually. So this order will be changed if you compare this with this electromagnetic force. You can compare with respect to weak force. You can compare with respect to electromagnetic force. But this is the relative strength. Just you can compare the force how much stronger from one to another. Okay, so these are the things. Now this is very important, that is exchange particle. These particles are actually responsible. These particles are actually responsible for this strong force. Okay, here you can say here mesons, gluons, photons, intermediate boson, gravitons. So for particular force, there is a particular types of exchange particles are there. That exchange particles actually responsible for these forces. So actually in microscopic point of view, if you say about microscopic point of view, what is the reason of these forces? The reason is nothing but exchange of some particles from one to others. As you have heard, might have heard about the nuclear forces, that pi meson is exchanged. Okay, so these are the mesons, like gluons. These are the exchange particles which are responsible for a strong force. Similarly, the photons are responsible, exchange particle or photons are responsible for electromagnetic force. Similarly, intermediate bosons like W bosons and Z bosons are actually responsible for weak interaction. Similarly, graviton, there is a particle called graviton, is responsible for gravitational interaction. So these exchange particles, and these are actually the particles who feels these interactions. There is a difference. These particles are actually feels this interaction, and these particles are actually responsible for this interaction. So these particles are actually the cause of interaction, you can say. If we talk about the interaction in terms of exchange of particles, or if you want to know the microscopic reason of these forces, these fundamental forces in atomic level, in molecular level, then you can understand or that these are actually the reason, these particles are actually the reason. As you know, or as you might have heard, the nuclear force. For nuclear force, there is pi meson particles are responsible, as they are exchange from neutron to proton, proton to neutron, and they create a force that is called a nuclear force. That is actually a special type of strong force. Similarly, any types of interaction, in the same way, any type of interaction is happening, and for there are special kinds of particles which are exchanged from one to other, and they are actually responsible for that force. Okay, now what is the effect? They are actually the cause. Why these interactions appears? Due to these kinds of exchanging particles. And the effect is that what this strong force do? This strong force, due to this strong force, actually nucleons are held together, that you have heard in your previous classes. Okay, so I will be discussing in more detail about this nuclear force in nuclear physics when I will talk about nuclear physics in this courses, in this course for JEE Main and NEET and JEE Advanced. I will tell you how this is happening, how the exchange particles create force, etc., etc. I will tell you. But now you just need to know this. Okay, and electromagnetic, you know, holds atom together due to electromagnetic interaction. Interatomic force, you know, interatomic force. So due to interatomic force, the atoms are holds together. So this is the effect of electromagnetic force. Similarly, weak force, this is responsible for beta decay. Due to this weak force, beta decay is happening in the nucleus. We'll discuss over here, discuss in these things in nuclear physics. Similarly, gravitational force, you know, formation of stars, galaxies, etc., all the celestial objects. Okay, they feel actually gravitational force, and due to gravitational force, there are formation of star, galaxies, etc. Okay, so these are actually the four fundamental interaction, and all the things I have written over here using this table, which is taken from a famous nuclear physics book, that is S.B. Patel. Okay, and I used here a code to relieve you from all these things. Okay, the physicist Enrico Fermi himself said that if I could remember the names of all these particles, I would be a botanist. He himself said, if I could remember the names of all these particles, I would be a botanist. Okay, so you don't need to remember all these things, all these particles, as he himself said. Okay, so you don't worry, you don't need to know all these things. But at some level, for exam purpose, you have to remember these things. That is for when you will be reading in particle physics. But now, this is not the topic of particle physics. This is just the basic classification of force. I just want to discuss about the four fundamental interaction. Okay, and just as a picture, you should know this. Because I will tell in the next class when I will be discussing with you about the classification of force in mechanics, that this tensional force is one kind of interaction, this normal reaction is one kind of interaction, this frictional force is one type of interaction, then you should actually understand. And you will be understand if you have at least a knowledge of this thing. Okay, so this is actually the basic interaction, in nature, the fundamental interaction in nature, and this is very popular. As a physics student, you should know this. Which are the fundamental interaction that are occurring in nature? There are only these four fundamental interaction. This is very nice, because in mechanics, when I will be telling you there is some types of force which is a contact force, non-contact force, balanced force, unbalanced force. There are various types of way of classify the forces. So you will confused that what is the actual classification of force. There is no actual classification. The classification depends on with what respect you are going to classify it. But if you talk about the fundamental interaction, that always means this four fundamental interaction, which is based on actually the exchange particles, the interactions are actually classified based on exchange particles. Okay, but there are these 4 kinds of interaction. This is a very basic thing. Okay, thank you.